And welcome, students. Beginning chapter 4 now. We will be talking about the integers, and we're going to cover fractions and decimals. Pretty exciting stuff. In this first section, these are the topics that we're going to cover. What are integers? Integers are all of our numbers that are positive and negative, and it includes 0, and it is our whole numbers. Now, fractions aren't included in this set. So first up, we began talking about the natural numbers, and these are the numbers that you naturally start counting with: 1, 2, 3, 4. You have a one-to-one correspondence with your fingers. The next set just includes a 0. Once again, no fractions in either of these sets. So when we're talking about natural or whole numbers, no partials here, no 1/2 or 2/3. Now here's a listing of the integers. You'll notice that it goes in either direction. What I like about this Venn diagram is it shows you all of the different numbers that you have studied so far in your math career. We looked at the naturals first. This is what we naturally start talking about our students with. Then we move on to including a 0. The integers includes all of the naturals and the whole, plus it also puts in the negatives in there with that. The rationals begin where you have the regular kind of fractions and decimals. The irrationals are those numbers that continue on and on without a pattern. In that rational, you would include 1/3 because it is any sort of integer over another integer. Would be the definition of a rational. So it'd be any 1/2 or -2/3, something of that sort. The irrationals are those weird numbers such as e. If you remember, we have this number e, we have pi, and any square root of a prime. That would also be included in your irrationals. And the real numbers are just all of those numbers. After that, you probably have looked at imaginary numbers before, and that is where you had square roots of negatives. Now, that's not in this Venn diagram. That's in another Venn diagram, all on its own. One of your questions in your homework has you talk about whether or not the integers are closed under each of these different operations. So let's go through what that means. Closure is demonstrated when you take any two numbers out of that set, and the answer will also be in that set. So if I took, let's say, 2 plus -4, the answer to that is -2. And is -2, or is that in this set? Yes, it is. No matter which two numbers that I pick out of the integers, the answer will be in that set. So addition is closed. Subtraction, if I take any two numbers such as -3 minus 5, that answer is -8. Now notice that -3 and 5 are both in the set of integers. Is that answer also going to be in the set of integers? And yes, it is. So subtraction is closed. Multiplication, take any two numbers such as 2 times -3. That answer is -6. Is that going to be closed under the set of integers? And you would say yes. Division, however, is another issue, because if I took, let's say, the number 1 and divided it by, say, -2, that answer is -1/2. However, -1/2 is not included in this set, so we would say that division is not closed or does not exhibit the property of closure. Negative numbers are used for negative profit, or losing money, if you will, or a checking account that's overdrawn. Below 0, if our temperature gets, and we here in Alaska get that. So just some examples of where we might use integers. Integers can be represented with vertical or horizontal methods, such as our XY plane that we typically graph on. Here are the different operations that we can use for integers and the different methods that we can use to teach these. Something that gets confusing for students when they're first learning to work with integers is that they wonder why the plus and minus signs are sometimes written up high as in a superscript, and this is supposed to be to avoid confusion, but sometimes it makes things more confusing for students. So when they see a plus 6 plus a negative 7, they wonder why it's written up high. It means exactly the same thing as if they'd have said 6 plus a negative 7, but it's written up high because this plus minus gets confusing. And so sometimes what they'll do is put it in parentheses if it's written just straight up with no superscripts. Of course, this is also the same as saying 6 minus 7, but then that's subtraction, so then it's not talking addition anymore. But you'll notice this different notation sometimes will confuse students, so you'll want to be sure and make a note of that whenever you are discussing operations of integers with them. When you're adding with integers, you can have a few cases that can exist. You can have both numbers are positive, one's positive, the other's negative, and you can have both of them that are negative. It's okay to make them memorize the rules, but it's best if you can use a manipulative and show why it is that two negative numbers added together will then give another negative number, or why a positive number and a negative number, it depends on which one has the greater magnitude. So a number line model is a real convenient way to do this. Here we're going to look at 3 plus a negative 4 with a number line model. So if we looked at 3 plus 4, that would be 7, but 3 plus a negative 4 means you go forward 3 and then backwards 4. That's so you can show that the negative is backwards. Sometimes I've done this by having students actually get up in the room and walk the space of the tiles that are on the floor. They kind of like that just because they get to get up, and that's kind of you put some tape on the floor and they can judge what the answer is by taking these steps going forwards and backwards. Absolute value, I'm not really sure that absolute value would be a good way to demonstrate this whenever you're first starting. Absolute value does tend to confuse students. Absolute value is just the distance away from 0. So if you were to say that you wanted the absolute value of negative 5, that answer would be 5 because it is 5 units away from 0. Same thing if you look at positive 5, it's also 5 units from 0. Students will get confused in absolute value and opposite. They are not the same thing. The opposite of positive 6 is negative 6, and the opposite of negative 6 is positive 6, but being opposite and absolute value, those are not the same thing. With that, we have the additive inverse. Additive inverse means whatever number that you pick, such as 5, his additive inverse would be what can you add to 5 to get 0. So his additive inverse would be negative 5. Likewise, if I chose negative 5, his additive inverse, what can I add to it to get 0? His additive inverse is a 5. Now, I'm not sure why they did another case where one's positive and one is negative, but I guess they did the first one and the second one. I don't know why they even bothered to do that, but they did. I'm not going to discuss that too much because case 4 is where both numbers are negative, and this is where a student would just walk backwards and then walk backwards some more. Subtraction is a little bit more difficult for students. So looking at subtraction in terms of just an A minus B, as long as both of A and B are positive, that's just straight up most students get that. The next case where you have where you're already negative, so you're in the hole 60, and then you write another, oh no, this is your fine $15, meaning you're going back 15 more. That one is a little bit trickier for students, understanding that this and this problem are the same. That'll be the key to kind of helping them understand the concept. And here they are just talking about it again and saying that you're down 75. One of the things that I like to do when I discuss this, I just talk about being in a hole, and you can you can put stairs on it or whatever, or you can, I've done it with a ladder. I'll put a ladder on the board and say, okay, if you are down however many steps and then you're going to go down some more, where would you be? And I look at it as up and down. Students seem to like that a lot. And this is probably the trickiest one of all for students. So one day, if the high temperature is -6 and at the North Pole the high temperature is -64, how much warmer is known than the North Pole? So you might look at that as what's the difference between those two numbers. So if you were sitting here at -6 and you're sitting here at -64, how much warmer? So really what you're doing is looking at what's the distance in between these two numbers, and let's see how that'll be represented. So if you'll notice, same thing with that number line model that I had before. How much warmer is it? It's 58 degrees warmer. And where'd they say that it was? Oh, let's see. Nome than it is in North Pole. So looking at that again, -64, -6, and really what you're looking for is what's the difference in these two. So here's how that would be represented, and that minus minus then becomes a positive. That's a tricky one for students. But it all depends on, you know, what it is that they're looking for. And we're looking for how much warmer is it? Well, it's 58 degrees warmer in Nome than in the North Pole. So here we just have our multiplication. You can look at this as 5 -3s. That's a good way to look at this. So because multiplication actually represents repeated addition, so I kind of like this method here to say how many how many is this, and this would be -15. So 5 -3s is one way to look at this one. Now in looking at my multiplication and division rules, they are the same basically. If you have a positive and a negative number, that answer is negative, whether you're doing multiplication or division. If you have two negative numbers, that answer is positive. And I believe that's all of 4.1. Alright guys, if you need anything else, be sure and email me.